Solve the given second order homogeneous linear differential equation with constant coefficient. Second derivative of y with respect to x plus 2 first derivative of y with respect to x plus 5y equal to 0. So this is the given second order homogeneous linear differential equation with constant coefficients 2 and 5, and you have to find out the solution of this second order differential equation. Solution means we have to find out y, the value of y, which is the solution of this differential equation. So the given differential equation, second derivative of y with respect to x plus 2 into first derivative of y with respect to x plus 5y equal to 0. Suppose this is equation number 1. Let the solution of the equation y equal to e to the power mx. So first derivative of y with respect to x will be equal to m e to the power mx. The second derivative of y with respect to x will be equal to m square. If you take the derivative of this term, then m square e to the power mx. Now we put the value of y, first derivative of y with respect to x and second derivative of y with respect to x in this equation, that is in equation 1. So putting y, first derivative of y with respect to x and second derivative of y with respect to x in this equation 1, we get second derivative of y with respect to x is m square e to the power mx. So m square e to the power mx plus 2 into first derivative of y with respect to x, that is 2 into m into e to the power mx. So 2 into m into e to the power mx plus 5y, that means 5, and y is equal to e to the power mx. So 5 e to the power mx, which is equal to 0. So this will be equal to 0, and if you take common e to the power mx, then in the bracket you have m square plus twice m plus 5, that will be equal to 0. So e to the power mx is not equal to 0 because this is the solution. We have taken this is the solution of the given equation. So m square plus twice m plus 5 will be equal to 0, and this equation m square plus twice m plus 5 equal to 0, suppose equation number 2, this is called the auxiliary equation or characteristics equation. And now we will solve this auxiliary equation or characteristics equation. Basically it is a quadratic equation to find the roots of the equation. To find the roots of the equation, as we know, the roots of the quadratic equation is minus b plus minus b square minus 4ac divided by 2a. This is the standard formula. So minus b means minus 2 plus minus b square means 2 square, that is 4, minus 4ac, 4 into 5, that is equal to 20. So 4 minus 20 divided by 2a. Here you have coefficient a. So 2 into 1, that is equal to 2. So that will be equal to minus 2 plus minus 4 minus 20, that is equal to minus 16. So square root of minus 16 divided by 2. So you have two roots. One is minus 2 divided by 2, that will be equal to minus 1 plus minus, and square root of minus 16, this is equal to 4 into 2. So 4 square root is 2, 2 cancels, so only 2 into square root of minus 1, that is I. So you have two roots, one is minus 1 plus 2i, another one is your minus 1 minus 2i. So you have two roots. Let us take one root is m1, that is equal to minus 1 plus 2i, another root is m2, that is equal to minus 1 minus 2i. So these two roots are imaginary and complex. Okay. So now let us find out the solution of the differential equation. So first solution will be equal to c1 e to the power m1x, and second will be c2 e to the power m2x. So the solution y will be equal to c1 e to the power m1x plus c2 e to the power m2x, and m1 one root is minus 1 plus 2y into x, and another root is m2, that is equal to minus 1 minus 2y into x. So if you multiply x here, so this will be equal to minus x plus 2y into x, and if you multiply x here, and then it will be minus x minus 2y x. So from these two factors, if we take e to the power minus x common, then this term will be equal to c1 e to the power I 2x, and from this if you take e to the power minus x common, then you have c2 e to the power minus I into 2x. And as you know, e to the power I 2x, this is your cos 2x plus I sin 2x, and e to the power minus I 2x, that is equal to cos 2x minus I sin 2x. So from cos 2x, and here also you have cos 2x, if you take cos 2x common, then you will have c1 plus c2. So c1 plus c2 into cos 2x plus I, if you take sin 2x common from this term and this term, then the bracket you have c1 minus c2. So I into c1 minus c2 into sin 2x. So this is another constant. If you take c1 plus c2, a constant c, and c2 minus c2, another constant d, then the solution y will be equal to e to the power minus x c cos 2x plus d sin 2x. So this will be the required solution for the given second order homogeneous linear differential equation with constant coefficient. Thank you.